In a darkened auditorium in Beijing, on the evening of April 21st, CATL's chief scientist walked to the front of the stage. He did not open with a story, he opened with a number, 3 minutes and 44 seconds. That is how long CATL's newest production battery takes to charge from 10% to 80%. Verified headed to vehicles, not a concept, not a footnote. 3 minutes and 44 seconds. 6 weeks later, on the other side of the planet, Shell, one of the largest oil companies in human history, held a press conference about a car that charges in 9 minutes and 54 seconds, and called it a breakthrough. Both companies are right about their own numbers, but they are not playing the same game. Shell's car will never be sold. A French oil company demonstrated the same cooling technology on a production Volvo 4 years before Shell's press conference, and the most affordable electric vehicle on Earth, a $10,000 Chinese hatchback with LiDAR, already matches Shell's efficiency target. So why did Shell spend millions building a car they never intend to sell? Stay until the end. You'll understand exactly who Shell built it for. It is not you, it is not me, and it is not anyone in Detroit. On April 2020 in Beijing, CATL held what it called the most technology-dense product launch in its history. 6 battery products, one night. The company's chief scientist walked out and said that lithium iron phosphate batteries are approaching their theoretical energy density limit. Then he showed the audience what comes next, a battery that charges from 10% to 80% in 3 minutes and 44 seconds. Not a lab sample, not a rendering. A production-ready cell already headed to vehicles, 3 minutes and 44 seconds. Let that sit for a moment. The average person spends more time deciding what to order at a drive-thru. Now hold that number. Because 6 weeks later, on the other side of the planet, a different company held its own press conference. Shell, one of the largest oil companies in human history, unveiled what it called a breakthrough electric vehicle, the 1010 Challenge concept car. Efficient, lightweight, and capable of charging from 10% to 80% in 9 minutes and 54 seconds. On a 175 kilowatt charger, the kind bolted to service stations across the US, the UK, and Australia right now. Shell's number is genuinely impressive. On hardware that already exists everywhere, 9 minutes and 54 seconds is faster than almost any production EV on the road today. But CATL published their number first, and their number is 3 minutes and 44 seconds. That gap, 6 minutes and 10 seconds, is not a rounding error. It is not an asterisk. It is the distance between a company announcing what is possible and a company already shipping it. CATL holds 40% of China's battery market as of the first quarter of 2026. More than 25 million electric vehicles worldwide run on a CATL cell right now. Shell has built one car. It will not be sold. So the question worth asking is not whether Shell's technology is impressive. It is. The question is, impressive compared to what, and impressive for whom? But here's the part Shell's press release didn't mention, and the part that explains everything. Here is something Shell's press release did not mention. In 2022, a French oil company called TotalEnergies quietly replaced the battery cooling system on a Volvo XC90 plug-in hybrid with a dielectric fluid of their own design. No press conference, no concept car reveal. Just an engineer, a modified production vehicle, and a proving ground. The results were immediate: faster charging, better thermal control. No modification to the vehicle's existing architecture. That was 4 years before Shell unveiled the 1010. In early 2025, TotalEnergies went further. They integrated the same immersion cooling approach into a fully electric Renault Megane, a mass-market vehicle built for ordinary roads. Charging time dropped by 50%. Range increased by 6%. Again, no fanfare. So let's be precise about what Shell actually built, because precision matters here. Shell did not invent immersion cooling for electric vehicles. TotalEnergies demonstrated that in 2022. What Shell built, and this is genuinely worth noting, is the first roadworthy vehicle to prove that a single cooling circuit can manage the thermal load of an entire powertrain simultaneously. Battery cells, electric motor, power electronics, all bathed in the same Shell recharged electric fluid, sharing one circuit, one radiator. That is a real engineering achievement. It simplifies the architecture. It reduces weight. Shell claims it cuts battery pack cost by roughly 25% compared to a conventional EV. But here is where the numbers become interesting. Shell's concept car weighs a target of around 1,000 kilograms. It uses a 32 kilowatt-hour battery pack. It achieves 10 kilowatt-hours per 100 kilometers. In May 2026, BYD launched the updated Seagull, 38.88 kilowatt-hours, 405 kilometers of range on CLTC, sub 10 kilowatt-hours per 100 kilometers on China's official test cycle. LiDAR driver assistance as a standard option. Starting price, $10,300. The Seagull is not a concept. It is not a proof of principle. It went on sale May 11th. Nearly 450,000 units of the previous generation were delivered in 2025 alone. Shell spent years developing a fluid that makes a smaller, lighter, more efficient battery possible. BYD spent those same years building the smaller, lighter, more efficient battery. One company made the ingredient, the other made the meal. In April 2026, Mercedes-Benz opened order books for the new EQS 450 Conct. This is Europe's flagship electric sedan. 926 kilometers of WLTP range, an 800-volt architecture, peak charging at 350 kilowatts. Starting price in Germany, €94,403. Its best-case energy consumption figure, 15.4 kilowatt-hours per 100 kilometers. Shell's concept car targets 10. BYD's $10,000 Seagull is already under 10. On China's test cycle, that is not a gap between a concept and a production car. That is a gap between two different philosophies about what an electric vehicle is supposed to be. Mercedes builds a cathedral, China builds the road. Now here is the twist. Shell knows this. Shell has known this for some time. On the same day Shell unveiled the Triple 10 Challenge, the company announced it was consolidating its entire electric vehicle business under a single brand. Shell Recharge, Charging Network, Battery Solutions, and the Thermal Fluid. They retired the old EV Plus name. Everything folded into one offer. Shell is not trying to sell you a car. Shell is trying to sell the fluid that goes inside the next generation of batteries, at scale. Their target customer is not a family in Ohio deciding between a Seagull and a Camry. Their target customer is an engineer at a Chinese OEM deciding which dielectric fluid to specify for a 50 million unit production run. The Triple 10 is a product demonstration. The audience is not YouTube. The audience is Shenzhen. Think about what that means. Shell spent decades extracting the fossil fuel that powered 100 years of internal combustion. Now they are formulating the fluid that will cool the batteries replacing it. Same chemistry expertise, different molecule. The transition didn't beat Shell. Shell quietly walked through a side door and started selling to the people doing the beating. Mercedes-Benz EQS, 15.4 kilowatt-hours per 100 kilometers, €94,000. BYD Seagull, under 10 kilowatt-hours per 100 kilometers on China's test cycle, $10,300. That is not a gap, that is not even the same conversation. And somewhere in a Ningde procurement meeting, a Shell sales representative is sitting across the table from a CATL engineer, with a bottle of Shell Recharge thermal fluid and a very straightforward pitch. Shell has announced a target of 200,000 public charging points worldwide by 2030. Not 200,000 cars. 200,000 chargers, with Shell Recharge fluid in the cooling systems of the batteries plugging into them. That is the business. That has always been the business. The Triple 10 Challenge will not reach a showroom. Shell said so themselves. Total Energy's immersion-cooled Megane has not entered production. The technology that both companies spent years proving is real, genuinely real, is being deployed at scale by neither of them. CATL shipped its third-generation Shenxing battery in 2026. 3 minutes and 44 seconds, 10% to 80. B shipped the updated Seagull in May, $10,300. LiDAR, sub 10 kilowatt-hours, sold. There is a pattern here that the press releases don't quite say out loud. The companies that invented the ingredients are holding press conferences. The companies building the meals are filling order books. This does not make Shell's engineering less real. The single-circuit cooling architecture is a genuine contribution. The fluid works. The numbers are verified on a proving ground in the English Midlands, but verified on a proving ground and shipping to 450,000 customers are two different sentences. In this industry right now, they are the two most important sentences in the world. The question is not whether immersion cooling will change electric vehicles. It will. The question is who will be remembered for changing them. Shell made the fluid. China made the car.